All right, guys, we're going to do some notes on 4.1 here. So in 4.1, we're going to graph polynomial functions. We're going to start with factored form. So you can see here there's a factored form one. And then next page we'll do not factored, where we factor it first and then we graph. It becomes basically the same problem as the first one. So a couple things. These are important things to help us graph end behavior. So like, what is your graph doing? And I'll give you a visual of this. Think about like x squared, it goes up to the left, up to the right. X cubed is where it goes down to the left, up to the right. There's also like down to the left and right if you have like a negative x squared, and then up to the left, down to the right with like a negative x cubed. Okay, so there's always something going on in between here in the middle of the graph. We're just talking about the end behavior as we go from left to right. Okay, so all the way to negative infinity with our x values, what's happening, and all the way to positive infinity with our x values, what's happening. So the two things that determine this are the degree, which is your highest exponent, and that's only if you're in standard form. I'll say SF for standard form. Or if you're in factored form, you add all the exponents on the factors, okay? But we say it's the highest exponent from standard form. So if you're not in standard form, you can't just look at the highest exponent. We'll talk about that in a little bit here. So your degree is either even or odd. If you are even, okay, if you're even, think about an even function from chapter 1. You're going to mirror the end behavior on the left and the right side because you have symmetry over the y-axis. So remember, x squared was an even function. It was symmetrical over the y-axis. Negative x squared was symmetrical over the y-axis. So if you are even, there's going to be that symmetry of either both going up or both going down. Okay? If you are odd, you're going to look like this x cubed or the negative x cubed. It's going to be the opposite. Think odd opposite. Okay, one side's going to be going up, the other side's going to be going down with your end behavior. So that just helps us determine if the two sides, left side and right side, will match. But how do we know which one's going up, which one's going down, vice versa? That's going to be determined by the lead coefficient, right? So if you're looking at an x to the third function, the coefficient on your highest exponential term, so the x to the third's coefficient, if that's positive or negative, that'll help determine the other piece of the puzzle for the end behavior. So this positive negative is really going to describe the right side as x goes to positive infinity, is how you learn that in Math 3, I believe. If your lead coefficient is positive, okay, let me do a different color here. If you are positive, you will end on the right side going up. And if you are negative, you will end the right side going down. And then even or odd will tell you if the other side's going to mirror that or if it's going to be the opposite. We'll do a few examples with that. Next is your zeros. These are your x-intercepts. Very important. These can only be found in factored form, or at least most easily can be found in factored form. So like I mentioned before, if we're not in factored form, we're going to factor first before we graph, because that's how we can easily identify what the zeros are. Okay, multiplicity. This tells you your behavior at your zeros, okay, or at your x-intercepts. Are we going to cross the x-axis at the intercept? Are we going to bounce and head back the other direction? Or are we going to wiggle across? Multiplicity refers to the exponent on each factor. Okay, so if you have a multiplicity of 1, okay, if it's to the first power, you're going to cross at that 0. If you bounce, that means you have an even multiplicity, meaning your exponent's 2, 4, 6, 8. It's an even number. And if you wiggle across, that's when you have an odd exponent, or an odd multiplicity, other than 1. So if your exponent is 3, 5, 7, 9, you're going to wiggle. If it's 1, that's just going to cross. So let's go through one example here. I think they're easiest if you just kind of walk through them. This is a fully factored function. It's an easier one to graph because we need it in factored form. So before we start, what do we know in factored form? All right, what we know in factored form is the zeros, which generate x-intercepts. What we don't know is the degree, because we're not in standard form. But we do have a shortcut that I'll show you once we start talking about the end behavior over here. Okay, so determine the end behavior. What degree is this? We said we don't really know the degree, but if I were to distribute this out, like if I were to do x squared times x minus 2 times x minus 2, I would need that 3 times because it's a third power. If we were to do that, these are all x to the firsts now. When I multiply x squared times x to the first times x to the first times x to the first, we add those exponents. This will end up being x to the 5th power. Okay, so I know I don't have it in standard form, but if we add these exponents of 2 and 3, we know that's going to be a 5th degree polynomial. So it's a degree 5. The lead coefficient, look at your coefficients in front of all the variables. It's 1 everywhere. So it's going to be 1 times itself a bunch of times. Your lead coefficient is going to be 1, which is positive. So my end behavior, because I have degree 5, it's going to be opposite on the left and right side. And the lead coefficient positive tells you that we're going to go up at the end. So the beginning of this must be down. And I'll have something going on in the middle. We don't know what that's going to be from the end behavior, but I do know left and right side are going to be opposite, and we're going to end on the right side going up because of that positive lead coefficient. Determine your zeros. I'm going to take each of these factors and set it equal to 0. Right? That's just x equals 0. I should have just done x and not x squared. You don't need the exponent. X minus 2 equals 0, so I get x is equal to 2. So I'm going to have intercepts at 0, 0, and 2, 0. Okay, 0, 0. Let's determine the multiplicity. That came from x squared, right? It's really like x minus 0 squared. So the multiplicity is 2. So we'll say multiplicity is 2. And then at 2 comma 0, the multiplicity of that one is 3 because it came from x minus 2. So multiplicity of 2 means I'm going to bounce off of that intercept at 0, 0. Multiplicity of 3 means I'm going to wiggle through the x-axis at that 0. Next, we're going to calculate the y-intercept. Remember, I can plug in 0 for x to get the y-intercept. So I'm going to have 0 squared times 0 minus 2 cubed. I think that's going to give me negative 2 cubed is negative 8. So let's go ahead and sketch. First, plot your x-intercepts. So we have 2, 0, 0, 0. Second, let's do our end behavior. So I want to attach my end behavior to the leftmost and the rightmost intercept. I only have 2 here, and I know it's going to look like this. So I'm going to start down to the left, up to the right. I don't know what's going to happen in the middle yet. Third, I want to do my cross. That's not a C. I'm going to do my cross, bounce, wiggle. This is for our multiplicity. So I like to move from left to right because we can attach to the end behavior. So as I move left towards 0, 0, I know I'm going to bounce at 0, 0, which means hit it, don't cross it, turn back the other direction. Now I know I have to curve back upwards to get to 2, 0, and when I get there, I'm going to wiggle through. So we don't know how far down this is going to go before we turn directions. That's not so important at this stage in the game, but wiggle means I go from steep to flat to steep again. And that's, yours is going to look messy, but that's okay. But that's our graph for number 5. That's as specific as we need to get at this point. Your fourth step would just be verify your y-intercept. We should have probably plotted it, but I did because it was covered by this x-intercept. All right, let's talk about the next one. Standard form. So now I have an x cubed plus 3x squared. Notice the difference from factored form to standard form. Okay, you can't do anything until you factor. So first thing I'm going to do, this is 4 terms. I'm going to try factoring by grouping. So let's see, I would have x squared, x plus 3 minus 4, x plus 3. That's going to give me x plus 3, x squared minus 4. You want to factor all the way. I see a difference of squares there. So it'll be x plus 3 and then x plus 2, x minus 2. So I have factored form, and we also have standard form. So what do we know in standard form? Well, we know the degree. Look at the highest exponent. Okay, we're not adding exponents. That's a common mistake. That's only for factored form. This one, we're looking at the highest exponent of 3. What we don't know in standard form is our zeros. That's why we factor. So this is degree 3. Okay, so that's odd, which means it's going to be opposite end behavior on both sides. Our lead coefficient, the coefficient on your biggest exponential term, so that's 1, that's positive, which means I'm going to finish going up to the right. So this will be down to the left because it's degree 3 means it'll be opposite behavior. So we should look something like this. Again, we don't know what's going on in the middle just yet. And yeah, now we can get going with the graph. So determine your zeros. I'm going to look at factored form. So I think we can see I'll have a 0 at negative 3, comma 0, right? I'm setting each of these factors equal to 0 in solving. Negative 2, comma 0, positive 2, comma 0. Multiplicity at each is 1 because these are all first power. Okay, so I don't want to write those again. Multiplicity of 1, same. So I'm going to cross, cross, cross. Multiplicity of 1 is the only time you'll cross. Let's see. Okay, I don't know why that moved. Let's see. All right, let's go ahead and start graphing. Let's get the y-intercept. Here's the other thing from standard form. When you plug in 0, all these terms cancel because they're multiplied by x or multiplied by 0. So that constant is going to be your last, that'll be your y-intercept. But again, it's f of 0. Plug it in if you're not sure. Calculate it. You could do this from factored form and you'd get negative 12 also. Okay, let's graph. So first step, x-intercepts. We have negative 3. Negative 2, positive 2. Second step, end behavior. Let's see, down to the left, up to the right. Now we get to the middle section. Cross, bounce, wiggle. Work from left to right. I know I'm going to cross at each one. So I'm going to cross at negative 3. I'm going to have to turn down and cross at negative 2. And then keep in mind your x or your y-intercept, it would be down at like negative 12. You're going to have some pretty large y-intercepts, large negative, large positive. So if you run out of space, just put it down. Like if I had negative 200 for my y-intercept, I'm not going to scale it and actually go down to negative 200. Just go off the numbers, label it as whatever it is. So this is negative 12. And my pen has stopped working. Okay, I don't know why that's not working, but we would continue down, hit the y-intercept, and then turn back up and cross at positive 2, at 2, 0. So that hopefully gives you an idea for graphing. There's going to be some practice to go with this, but yeah, nice job. Thanks, guys.